Hello everybody, how are you? I'm fine, thanks to God. So in this particular paper review session, basically you will see the main and the very important parameter in a control algorithm, so-called super twisting algorithm. So in this super twisting algorithm adopted system dynamics evaluation in a control system, the writer, especially the researcher, basically focused on the super twisting algorithm. So the advancement and the necessity of super twisting algorithm for the controller, so-called sliding mode control. So the sliding mode control, the one abundant problem is chattering problem. So in order to reduce a chattering effect from a plant dynamics, basically adopting such kind of super twisting algorithm in a system is a very fundamental thing we have to know during the controller selection and during the design as an researcher, as an advanced academician. So in this particular lesson, starting from this point, I have already done on the super twisting algorithm when I was in a campus, especially when I was studying my second degree in mechatronics engineering. I used super twisting algorithm to reduce the chattering effect at the actuator side in my plant. So, and here the higher order super twisting algorithm is a very important parameter to reject such kind of chattering effect from the plant dynamics. So you have an opportunity, you may have an opportunity to look at such kind of papers from journal sites, so-called IEEE Explorer, so-called like Library Genesis, and so many other research paper uploading sites. So go to there and search for the papers based on the keyword super twisting algorithm, and you will see that algorithm abundance in so many plant dynamics. I don't care about the plant system, but I'm speaking about the controller system. So you may select any system you need in your study, but my point in here is just not to speak about the plant, but I'm speaking about the genuinity of this particular controller algorithm, so-called super twisting. So if that is so, let us go to my research paper proposal, and we'll see some basic dynamics of the difference and the necessity, especially the merit and the demerit, or the advantage versus the so-called the disadvantage of the algorithm, so-called super twisting algorithm in a system. So as you can see from here, this is basically a form of paper which is proposed for my master's program when I was there. But now my point in here is just how to just reject such kind of a system. So in my design, I selected a super twisting algorithm for my plant dynamics controller. So that is sliding mode control. From that sliding mode control, basic approach of my system is so-called terminal sliding mode control, which is terminal sliding mode control, TSM, which is so-called terminal sliding mode controller, so which is TSM. So the point in here is not to speak about that, about the demerit of this sliding mode controller, and why we use so-called super twisting algorithm to manipulate, or in order to make our system advanced. So in order to reject such kind of effects, the noise effect, the chattering effect, and other the robustness effect from the system dynamics, it's better to robust our control algorithm in order to get accurate output. So in order to get accurate and the needed, the wanted output, we need to have algorithm or the controlling system, so-called super twisting. Here are some important parameters I wanted to tell you right now here. So the point in here, as you can see, is my control system is so-called super twisting algorithm, as you can see from here, which is my controller. So I selected the super twisting algorithm for my plant dynamics. I will show you later on where is my plant and where I adopt this controller mechanism in order to need the required output. So the controller is so-called super twisting algorithm. But before that, I selected the terminal sliding mode as controller, so-called TSMSC. So once I select this thing, I directly put my eye into the demerit of this controller. When I look the demerit part or the disadvantage part of this terminal sliding mode control, there is a singularity problem. So this is a very popular and a very known problem in controller system, the control design of a mini dynamical system. So a singularity problem means that the entire system matrix determinant is zero. So in order to reject that zeros system from our modeling system, we need to reject such kind of zeros. So for that case, this sliding mode control, terminal sliding mode control, will never omit that singularity problem, will never reduce that singularity problem. The singularity problem in this controller case is higher. So I have to shift the point of a control system. So then after, in order to solve this demerit part, I come to here and I select so-called non-singular terminal sliding mode control. That is in order to reduce the problem of singularity. So once I select the singularity problem rejection mechanism, I selected here non-singular terminal sliding mode controller, and then after I look for two things. The first thing is what the advantage of this non-singular terminal sliding mode control. When once I adopt that sliding mode controller system for my plant dynamics, where is the output? When I look the output, the merit part, so the demerit part and the demerit part. Before I goes to the demerit part, the merit part is our system is a very fast response, which have a capability to just to give us the robustness, and again we have a finite time convergence. So our convergence, the final output controller convergence is finite time, which is not infinite time, which is so-called the advantage or the merit of this non-singular terminal SMS. Look at here, which is robust, again, which is a finite time convergence. So these two things are the main advantage of the non-singular terminal SMS. So here the demerit is again chattering effect. Here is the singularity effect. When you come to here, the demerit of this the non-singular terminal sliding mode control is a chattering problem, which is not reduced in the well manner when we used such kind of controller for our plant dynamics. So in order to reject from my system is an unmaterial vehicle when I use that system in my dynamics. So in the demerit part, the chattering effect is the main effect or the main problem when I use this non-singular terminal SMS for my plant. So I have to shift the point of my looking to another dynamics in order to reduce that chattering effect. For that matter, I came and I shift my controller to super twisting algorithm. As you can see from here, in order to solve this chattering effect from here, I directly select super twisting control of terminal sliding mode controller, so-called super twisting control of TSMC, which is for my plant UAB. So in order to solve the demerit part, I used this super twisting algorithm or a super twisting control of terminal sliding mode controller. So the lesson in here I wanted to share to all of my family, I wanted to share is just in order to get a chatteringless output, we need to select a good performance control algorithm for our plant dynamics. So that is the very important point I want to share to all of you. So which is so-called a controller system. So the controller selection is came for my hexacapta UAB, which is actually done in May in 2009, which is 3 years before. So the main concept is just in order to reduce such kind of a chattering effect, so we need to select the super twisting algorithm. So this is the first, I think, from the theoretical. I think I have covered the so-called sliding mode controller, the mathematical part, the mathematical analysis. But here is from the research point of view, I covered about the selection criteria of the control algorithm. So next time we'll see about the internal kinematics of this super twisting control algorithm of so many adaptation. Super twisting control algorithm with proportional, derivative, and integral controller, super twisting algorithm or super twisting control of terminal SMSE, super twisting algorithm with another controller systems with a biomanner. So this is it. Don't forget to be a family. Don't forget like, share, and subscribe to this particular channel. So thank you for this